Good morning, good afternoon, and good evening, everyone, depending on where you are. Welcome to our June OpenNTF webinar. Today we have a really exciting topic. It's one of the major new features in Domino V12, the Certification Manager with Daniel Nashed. So I'm just going to go through a quick couple upfront slides, and then we'll get right into the presentation with Daniel. My co-hosts today are Graham Akers, and we also have Jesse Gallagher. We're all three of us around the board of OpenNTF, as well as Roberto, I'm going to probably mispronounce your last name, Bocadoro, is also on the board of OpenNTF, and he's joining us as well. He's our admin expert on the board, so he's joined us for today. And at the end, we'll cover some Q&A. First, I'd like to thank HCL for basically making this possible. They've made a very nice donation to OpenNTF, which helps fund these webinars and many other things. And Prominic basically provides all the IT infrastructure for us. So thanks to both companies for supporting OpenNTF. Just a reminder, OpenNTF is a volunteer organization dedicated to open source code around the HCL product set for Domino and related products. We're always looking for people to help. So even if you're not a developer and don't have a project to contribute, if you want to help, just get in touch with us. You can go on our Slack channel. And I want to also mention our July webinar. We have some presenters, Stephen Wissell and Paul Withers from HCL, going to talk about Project Keep, which is a new API, REST API for Domino. So put that on your calendars and register. The registration is now open. Okay, so asking questions. Yes, this is going to be recorded. Please don't answer that question, as all our webinars are recorded. And also the slides will be put up as well on the OpenNTF site. We'll send an email out with that URL. So how to ask questions. There's a questions pane in your GoToWebinar interface. Just go ahead and ask your question there. We will not respond to your question in the questions pane. We will save your question for the end, and we will ask Daniel the questions then. So please ask questions as we go along, and we'll get to them at the end. We're going to save some time at the end. Any questions not related to what Daniel's talking about today, please post on our Slack channel. Daniel, I think we're ready for you. I know you have a lot of stuff to present. This is an exciting topic, something that I think Domino definitely was ready for, an overhaul of the certification process. So I'm going to make you the presenter.
Cool.
And I'll let you know as soon as, yep, we're seeing your slide there, Daniel. Take it away.
Very nice. So good morning, good evening, good afternoon, everyone. So it's afternoon here, late afternoon in Germany. Yeah, Howard said already most of it. So I'm presenting today as a HCL Lifetime Ambassador. And this is sponsored by the HCL Software Academy. And the topic that I have today, I will start with Cert Manager and everything that is related to Cert Manager. We first will cover up all the theory, and I will explain how it all works. And then we take what I explained in the slide material, and we do a live demo, a long live demo with all the details. And then we will see if we have many questions already, or if we go to the troubleshooting slides. The troubleshooting slides are more like already bonus material, because we don't have to go through all the details. I think it's more important to cover the features and explain the features. And last but not least, at the very end, I have some bonus material. If you want to build your own lab internally without external access, you can still do that with Let's Encrypt Pebble on your own machine without any external DNS provider. That's something that I added as slides, but we probably can't cover it unless we have time in the Q&A section. So let's start from the very beginning. So the design goal for Domino 12 in the certificate area is really to simplify certificate management. So most of you know all the stuff about keyring files and the kyrtool, and that you needed most of the time OpenSSL to create your keys and your certificate assigning requests. And that has been all completely changed. It's a complete game changer here. Then also one of the main questions that HCL got was Let's Encrypt integration. And it's not just Let's Encrypt integration, it's pretty much, there are many other ACME-based providers that you can also leverage, not just Let's Encrypt, but Let's Encrypt is the most famous and the most well-known and the best supported one. And also, when you change all the code that is related to certificate management, it was also important to simplify the flow for other external certificate authorities. And you will see in a minute how that works. I will show this in the demos. And this is very dramatically simplified. What is also something that HCL worked on is to change the way certificates and the keys are distributed. So we have a secure automated deployment of something that is now called TLS credentials. That is the key, the certificate, the chain, and the trusted root. And you will see in a minute how that is done. And of course, when you deploy everything automatically, why do you need to restart server tasks? So automated update of certificates, that was also a design goal. And last but not least, there's a newer standard for cryptographic keys. We have RSA keys for a very long time in Domino. Domino was the first product, or one of the first products to support commercial RSA cryptography. Now we have elliptic curve cryptographic, ECDSA, which you will see in all the different places. I have some slides covering that, but we will not go into all the details about that. So the technology used in the backend, it's a native server task. It's a DSRP filter for now to intercept the incoming requests. It leverages new and existing APIs on the Domino side, so it's all HCL code. And even the ACME protocol has been implemented using modern standards that are all part of Domino now. So it's really an own implementation, not just a library that you got from somewhere and implemented it and made it fit. So all the different parts of the protocol have been implemented, and it's really from what I see, one of the most sophisticated implementation and easy to use implementations on the market today. And of course, it's designed for automation. So let's go into details. The first thing that is important is the new cert store. The new cert store is a domain-wide database. It has a domain-wide replica ID that is derived from the Domino directory. So when you start it on your first server, it will be created. It's a secure database. All the private keys are encrypted with the Cert Manager server ID, and every server that you select to have a certificate for that server, the certificate will be encrypted, and only that server has access. Even the database replicates domain-wide. So there's the new encryption, and it works similar like the ID vault in the backend with the operations key that is encrypted with all the servers. So you will see it's easy to use and quite modern. It has complete new design. You see on the right-hand side already the navigation pane of the database. I have to say it's working on Windows and Linux. So the Cert Manager server task is only available for those two server platforms, but you can still leverage the database and the consuming part for the certificates on AX and OS400. So in case of those two platforms, you just replicate the database and the server knows how to use the certificates using the TLS cache, which I explain in a minute. So, as I said, the database is created automatically. The first server, and that is really important, you have to decide which server is your cert manager server. And on that server, you start cert manager for the first time. And this creates the database fully automatically. It puts in your local domain admins. If you need more admins, you just add them. And it writes a hidden field into the Domino directory profile on the admin server to propagate the cert manager server in the domain, that every other server that will start the cert manager server task will know when creating the database that it's a replica of the existing database on that cert manager server. So it doesn't need to be the admin server of the domain. You can pick any other server, but likely in many cases, it's the admin server of the domain. So for each additional server, it will be just the cert manager task will just run in client mode. That means it will create the database when you run it, and you can keep it loaded if you want to, but you don't have to. And when it's continuing to run, it will replicate the database from that cert manager server every 2 minutes. That is really optional. You can also have your own replication cycle, but this is built in to make it more convenient and that you don't need an explicit connection document just for that. So I mentioned already the new term, TLS credentials. And let me explain that again, because it's really important, because that term is used in many different places. So the TLS credential are the private key, the leaf certificate that is created that matches the private key, the chain, that means all the intermediate certificates plus the trusted root. All of this together is the TLS credential. And that's why many places call it TLS credentials, because it's the combination of all of this. So this replaces the KYR files that we all know and love. And the internal storage format is PEM format, which is a base64 encoded format that is plain text that you can copy around. So all the certificates, all the trusted roots and everything, you can look into them. They are in the document. You can copy them out. The only part that cannot be copied is the private key, which is also stored in PEM format, but encrypted inside the database. So the TLS credentials can be created either through manual flows, and that's something that I will demo. And also it can be created with the ACME protocol with Let's Encrypt and others. And when you replace the keyring files, you also have to replace everything else that is part of the KYR file. The KYR file also contains trusted roots for other certificate authorities that are needed for client cert authentication. And the idea was pretty much to replace everything in one go and have a central database that holds the TLS credentials, and you can really define which trusted roots should be used, and they are easy to import. You will see that also in the demo. So the trusted roots have a separate view and a separate form, and you just replicate them along with the database. They're used for the ACME protocol to complete the chain. So the trusted root from the ACME protocol is not part of what Let's Encrypt and others send you. So you have to include it in the database. So you will see when you create the database from scratch, it will contain already the trusted roots that are known today from Let's Encrypt for your convenience. But if you need more, you just import them, and it's a very easy flow. You just create a document, you paste it in, you submit the request, and then they are available with all the details. You see on the right-hand side here, oops. You see that you have all the details of the certificates, of the trusted roots, and also it gives you the subject key identifier, it gives you the expiration, the algorithm used, the size, the curve, and so on, right? It's designed for root certificates, but you can also use them for intermediate certificates. So it has something really nice built in. It completes complete chains. So it starts from the leaf certificate and goes up to the root, and everything that is not in what you paste in or what the ACME protocol sends over, it will be checked against the trust store and auto-complete it. And not only that, if you import a certificate and you paste too much data into it, or you place it in a different order, it will ignore all certificates not needed, and it will place all the certificates in the right order. So you don't have to care about the order of the certificates anymore on your own. So let me explain a little about ECDSA, because you will see it in all the different places in the database. You can select RSA or ECDSA keys. ECDSA keys have a lot of benefits. One very important benefit is they are shorter, and with those short keys you get very similar security than with a much longer RSA key. So on this slide you see all the details, which lengths of RSA key will be approximately which ECDSA curve, right? So usually 256 is fully sufficient, and Let's Encrypt currently supports up to 384. 512 is built into the code, but really that's something for the future. And as soon as Let's Encrypt would support it, it would be probably just a small design change in the database to enable that. So one important detail here, and I saw questions about that already in some places, when you enable ECDSA, the normal cipher configuration is not used, but instead, if the server has that key, it will automatically choose those two ciphers that are listed here on the page. And those are the two ones that are well known and well accepted in all the different applications. So for some more details, I put in a very interesting blog post from Cloudflare. I think they are the most compelling resource around that space. And this article really gives you all the details, so I don't have to cover them all and bore you with the cryptographic background of that. One additional thing is 2 new curves that also have been added, 2 more modern curves, and the most important one is the 25, 50, 19. It's on by default. You don't have to do anything, and it will be, you can disable it if you really need to, but those nodes and I parameters are just for completeness. I won't expect that anyone will change this except for testing purposes. So it's all in place, nothing to change, just go and you're fine. So manual certificate operations, that will be my first demo. And this is something that you all are using every time today when you need a certificate. So the flow is as follows. You create a new TLS credentials document. You put in the host name. You put in the server name that should have access. You change the certificate provider to manual because it's a manual flow. And then pretty much that is all you need to do. Everything else is optional. The key type and curve name will be based on the global configuration that you can change. So for a new TLS credentials document, that's all you specify. You can add like organization and so on, but the default organization is filled in already. So you go in and say submit request, close the document, and after a couple of seconds, you got a private key added to this TLS credentials document, and also a certificate signing request, a CSR. And in that step, what you see in the menu is an action button saying copy CSR. You don't even have to go into the manual tab to get the CSR here. It's all directly there. And once that is done, you just send that over to your CA or to your provider, whatever. And on the way back, you paste the certificate, say submit again, and you're done. So that's all you need to do. As easy as that. The next thing that is interesting here is once you got your certificate, you want to know, is your certificate valid? Is everything fine? You might remember from the QIR tool that it showed warnings and errors like the chain is not the last element in the chain is not trusted, or you don't have a certificate, or the order is not matching. This is also available here. That's part of the certificate health check. And you get the green, orange, or yellow and red status. And you get details about what is wrong. It could be more than one thing that is wrong with your certificate. In addition, this health check is going to check your certificates every 30 minutes, and it will be also used to automatically put certificates in renew state. So the default is 30 days before the certificate expires. That's something that you can change, and it would automatically go and try to renew the certificate. And if everything is fine, then all is green, but in some cases you might run into errors. So what has been added is also a way to check certificates, and I put some blog posts already out there to my blog saying how you can query those statistics. So you have a green, yellow, and red status, but you also have counters, and you could take the red and yellow counter and create a statistics event out of that to send you emails. So I get every morning, I get emails if something is wrong. So every 24 hours, it will go again and checks if still something is wrong. It will alert you every day. And that's the integration for the certificate heads. So what it has been also added is more details about the certificate that's in the form. But what is still there is the Examine Internet Certificates dialog that you all know. It looks exactly the same, and it will give you exactly the same information, just also for the new ECDSA certificates. So that was the first part, manual certificate operations, and that explained already a bit about how it all works. But the interesting part, the next interesting part is the Let's Encrypt and ACME support in general. So when you look into the AHA portal, you saw that there's a lot of interest in it, and there is a good partner solution, and kudos to Midpoints, and especially Ulrich Krause, who did this first implementation. They used a Java API in the backend to implement that, the Let's Encrypt protocol. And what HCL did is put it really into the core of the product. So it's part of the certificate manager, and it will build, and that's something that only HCL could do, right? So business partners can only extend it to a certain point, but really the full integration was only possible with all the flows and automatically updating as part of the product. So it's really easy to deploy, and you will see that in a minute. So the architecture looks like this. And this is really, I think, from the original design specification. So you have a couple of components. The first component is the cert store database that I spoke about already. We have the cert manager server task that is working with the cert store and is doing all the operations, and it's talking to Let's Encrypt over port 443. It could use a proxy, and it can also use authenticator proxies. And then we have a DSRP filter, which is intercepting incoming challenge requests. This could be either directly or through a load balancer reverse proxy. And this is really one of the important points. You have to have external port 80 access to your server. I will explain that in a minute in detail, what exactly the requirements are, because it's a very certain URL. And the flow is as follows. You put your certificate request into cert store NSF. The cert manager task will take it, will start the ACME dance with Let's Encrypt. At some point in the protocol, it will then say, okay, you have to prove that it's really you. And then it will give you a challenge. It's a secret that you have to put onto your Domino server. And in case of the certificate manager, it's stored in cert store. That also other servers in the domain, the DSRP filter doesn't need to be on your own server. It needs to be on the server that will handle the request, actually on all the servers that might get the request. And the DSRP filter will then communicate with the backend and check the cert store for the challenge and will present the challenge to the Let's Encrypt server. And then the Let's Encrypt server will say, okay, you have proven that it's really you. Now go ahead and ask for the certificate. And then the cert store is create again with the cert manager task and says, okay, here's my CSR. And then on the fly, the ACME protocol gives you a certificate. So that's the basic flow. There are much more details. Of course, you need an account. The account needs to be created. But this is really all part of the magic that is behind the cert manager and in combination with Let's Encrypt. Okay, I explained most of this already on the slide with the picture. What is important here is really, and I put this again in red, because this is where your customers, and if you're a partner or you as a customer, will have most questions. The inbound port 80 is a very strong requirement. You have to have the first request here. It can be redirected to something else. It can be redirected to the HTTPS port, but only on 443 if you have already a certificate. It can be an invalid certificate. It just has to be a certificate. And then Let's Encrypt will take that redirect and will query the well-known ACME challenge URL on that other port as well. And this is really the requirement. If you have like a load balancer before that, and you will want only to filter certain requests, or if you make the server not available for public requests and only authenticated, you put in HTTP public URLs, you extend that with well-known ACME challenge /star. I put one as an example that contains also a redirect database and also the multi-factor authentication configuration or a request URL, so that you have one that would work with a redirect URL, with the ACME challenge, and also with multi-factor authentication, the TOTP, that is also one of the highlight features in Domino 12. So, okay, now we're almost set. There's one thing that we need in place. It's the DSRP filter. You either do that manually, or you can say load cert manager -c, which will automatically put the DSRP filter name into your server document. It's only automated for the non-intersite net site configurations, because it might not be a good idea to automatically put it into all internet sites. So HCL decided not to look into all the internet sites because they could be also for other servers, right? So in future, and that's one of the feature requests that I saw, the DSAPI filter functionality will be probably added to the HTTP task, and there's no HTTP change that you need to do to load a DSAPI filter in future, hopefully. Okay, so once you have that in place, you need the Let's Encrypt configuration. And for convenience, the Let's Encrypt production and integration, also the staging environment, has been added to the search store template. And when you create the database, they're already there. The only thing that you have to do is you have to accept the license terms from Let's Encrypt. And I will also show that in the demo. So that was Let's Encrypt. There are at least 2 other providers out there that I know about. And if you have more providers, I would like to hear from you because I would like to test them. Those are the 2 other famous providers out there, ZeroSSL and Bypass. And there's one third provider, which is not a public CA, but it's something that you could run as a local CA in your environment, and it could operate even as a sub CA in your environment. So a sub CA in your environment would be probably you have most customers today have Microsoft CAs or any other CA, and you could create a sub CA and delegate this authority to create certificates inside your organization to this small step CA. And the small step CA has one component, and I did also a blog post about that. And this ACME CA can be used inside your company to use, for example, HTTP 01 challenges. So that's something that you could even set up on a Docker container in 10 minutes. I have it running for test environments as well. And it would be a very convenient way to integrate with what we have in Domino and Cert Manager. Okay, that was the easy part. Now we have the fun part before we go to the demos. So let me explain that in some detail, but we have to look into this with practical examples because it's a bit wild. So it is well integrated, but and the good news is that there are already some configurations out there that you can use out of the box, but it's really designed for partners and customers to add their own configurations. It has an own small API that can integrate with DNS providers, and that's the important part here. You can only use DNS challenges if you're using a provider that supports that you can automate adding DNS text records on the fly. So the protocol will ask you to put in a proof that you own that domain, not just the single host, the whole domain, and that enables you also to a very, very nice feature, and that's something many people waited for, and I'm using it all the time now in my environments, also for testing internally. That's the wildcard challenge certificates. So you can get through DNS challenges wildcard certificates, and I find that pretty cool, and that's really helpful in many environments because there's only a certain limit of certificates that you can request through the ACME protocol per month. And I would say if you can, if it makes sense, depending on the servers, I would go with wildcard certificates if you have a DNS provider that is supported. The next interesting thing is that you don't need an inbound connection on port 80, and the Cert Manager server can request the certificates for any server in your domain. So all the other servers in your domain are not needed for those kind of operations. So it's all handled by requests from the Cert Manager server to the DNS provider. And how can you do that? It's done by a REST interface in most of the cases, or it could be a nodes agent if really needed. So if you have a really wide configuration, you can call a nodes agent, and that nodes agent can do all the magic. Or if nothing else works, or if your provider has a command line interface, it could be a command line interface. But really, what works well and is very easy to use is the easy to use integrate REST interface. So how is that triggered? How is the difference between a server or a domain that or a host that is requesting HTTP 01 challenges and DNS challenges? There's a very easy distinguisher between them. So it's all done by the registered domain. So if you put into your DNS account, like in this case, that's one of my domains, csidomino.com, and it's using the Cloudflare integration that you will see in a minute. So this DNS provider account is using the DNS provider configuration for Cloudflare, which comes out of the box that you can download from a repository. And then you just configure your DNS zone and authorization keys and specify the registered domain. And pretty much this is what you have to do. And then the magic in the background communicates with the DNS provider. And of course, you have to have that authorization key that you need to generate. And then this is all triggered by the registered domain. So anything in this domain or any subdomain will be using DNS challenges instead of HTTP challenges, which is a very easy configuration step. So the admin requesting the certificate doesn't have even to think about what is the right provider, what have to be done. So it's all done automatically. So there are some already out-of-the-box providers. Cloudflare was the first one that was implemented. The second one was Hetzner, and another one is DigitalOcean, and something that is not yet available on the repository that I will show in a minute is the AWS integration. They have their own DNS and they have a more complicated API. It's using JSON and REST services, but on the CLI from AWS. And what I built is a command line integration to leverage their interfaces. And this will be available soon, public. So how do you import them or export them when you've written one? So the idea was really to make it as easy as possible. So it's all DXL. So it has an import and export button. And you just go and get the DXL document. It's a single file. It can have one or multiple entries. You import it through the menu, and then you have a new document. And the interesting part here is that, it is containing all the details, like what is the provider, it has the documentation, you will see that in a minute, and it's really designed in a way that others can contribute, and then you know where it's coming from, which API is used, and so on. So something new that I can announce today, it has been opened today, is a new Git repository for the Domino Cert Manager. It's part of the HCL Tech software repository, where we saw the DOMI integration for the calendar interfaces to different providers like Teams, SameTime, WebEx, and Zoom. So it's another repository here. that will over time get more and more configurations. Okay, how do you build this when you do your own? And I will cover that really just quickly. And this is something that probably, if you start looking into that, you can talk to the team doing that through the Git repository, ask questions and open issues and so on. But just let me give you a very, very brief overview. So it's a simple modern interface. It's most of the interfaces that the providers have is REST-based. So we have JSON payloads, and that really works well with add formulas. And what you need to do is have an add request and a delete request for a DNS provider. And then the configuration that you use later on is just that, right? Once that is built, you have all the details here, you have the documentation, and that's something that HCL expects from a provider of a new interface. Let's take a simple example. So here we have a post request, and you see very simple formulas, and I show that in my demo, and I will have 3 or 4 more slides, and then we take the demo because that makes it a lot easier to explain things. You see really it's all formula based, and what we added is built-in support for to insert fields, to have tracing, and also test the formulas even with example code. You will see that in the demo. And this is the request tracing. You see all the details here, but I will cover that in the demo. That's much easier. So one last piece that we shouldn't miss is the TLS credentials cache. So if you wonder how this all comes into play and how the TLS credentials will be loaded into the server tasks, there's something new. And it's not really highlighted, but it should be highlighted. Most admins, most customers will not really see it, but they will see what's happening. What's happening is there's a new modern cache that can handle ECDSA keys and RSA keys in parallel, and the TLS credentials will be read from the cert store directly. So there are no key files more on disk. It also decides automatically which is the right one, the ECDSA or RSA key, depending on the configuration. It will also check which is the best key. So if you have a wildcard certificate and a direct certificate for a server, it will always pick the one for the server. If you have multiple keys and one has a stronger key or a higher a higher curve, it will always take the higher one. And that's all built into the logic and the backend. And the cache sits invisible between the NTI layer and the internet task like HTTP and SMTP. And it's sitting somewhere in the SSL layer, which is really the foundation that is between the NTI layer, which is the network layer, and all the different tasks. So it's in parallel to the existing QIR cache, which is still there, but the new cache is hit before the old cache is used. So as soon as you enable the search store on the server, it is automatically on. You don't need to do anything. It all works out of the box. So that's why both here are orange. So the search store and the TLS SSL credential store are good buddies working together. So that is almost everything. I have one last slide, and this is very, very, very important because that's the part where you might run into trouble if you don't understand the concept that is behind it. So what I've just explained is something completely new, and it's a separate database, and it has all the names of the certificates, and it will understand all the requests, but not every server will use server name indication, And so you will always hit the server at the internet site, and we still don't know what the request is for, right? So even before the SNI request will be evaluated, if you have a server that has server name indication and gives you a hint which certificate to use, you need any kind of indication. And that's still, in most of the cases, the KYR file name. And the KYR file name, the key file KYR, is still the default name. And what you should do is, for the one that is the default for your server, you have to put that into the main TLS credential document for your server. You could also specify the host name, right? Those are the two options. So if you run into trouble, remember this, and there's also tracing available. We have Node CNI settings available to show you all the details. I will cover that later on in the remaining slides. But this is the main point here. But I will explain that again in the demo. So demo time. I hope you're all still awake, because that's a lot of theory, but it's getting easier when you see the demo. So I have my demo environment. I have no cert manager running. So the first thing that I will do, I say load cert manager on my first server -C. Let's do a live console. You will see it creates the database. It has created a new database. In my case, I'm using a different name because I don't want my Pluto server to have his configuration messed up. Start our demo. So we have a brand new database. It's almost completely empty. The only thing you see are the ACME accounts. And for the ACME accounts, you will have to go in once, accept the license terms, because if you don't do that, it will not work. The protocol will complain, and you will see a log messages from the protocol that that the terms of services are not expected. So that's something that you have to do first when you want to use Let's Encrypt. But what I want to show before showing you Let's Encrypt is showing you the manual flow because most companies will have the need for other certificates as well. And we take the demo from there and then go to the more fancy stuff like the Let's Encrypt flows that we have here. So let's start. Let's go and say add TLS credentials. So let's take my demo domain, csi-domino.com, and let's take OpenNTF, and maybe we take one with umlauts. You can put in whatever you want. In this case, that server, it's listening to all the requests. My DNS points to that server. Everything, every host that has no separate entry using a wildcard DNS entry. Just if you wonder how I'm doing that, this is really public DNS. This is not a mockup. This is live data, right? So the next step that you have to do is you go and put in the right servers. In this case, it's the Pluto server. This is an easy dialog coming from your Domino directory. I'm not going to the address dialog, but directly to the server documents. And you can open that here. And that's pretty much all you have to do. Everything else should be fine. You have an organization here. You can change that. You could change the key to ECDSA, and you will see that it will automatically switch over to the curves, and you can use whatever curve you want, one of the two that are supported. And in my case, I'm now not using the ACME protocol, which is coming out of the box. we go in and say manual. And pretty much this is all you need to fill in. You say submit request. And you see there's the waiting icon saying, okay, I'm waiting for the admin. You see we have the copy CSR here and paste certificate. So we don't have a certificate yet, but you see you already have a key assigned here. And you would have, here's the CSR, but you don't have to copy it manually. It is over here. You can say and copy CSR. So it's copied to the clipboard. Then you go to the CA of your choice. You paste in the request. You change it to web server, submit. In most cases, this will take a while. In our case, my CA is configured to just do it. So I download the certificate. I copy it over. Paste it in. And then it says, okay, certificate paste the submit request to finalize. Let's do that. Submit the request. And it's done. So it's yellow, but it's done, right? So I will explain in a minute why it's yellow. So you see that already. The last cert in chain is not self-sent, so no root found. This is a quite speaking message, and so you know that your trusted root is not in the trust store, right? So, but let's have a look. So you see the names here have been translated, and if you have a umlaut or other IDNA name, it will read the name from the certificate. So this is Punycode, and it shows both in the UI. You also will see all the details like the issuer, you see the certificate chain, and now you see the problem. It's only the certificate, no chain. So what do we need to do? So I have prepared something here. Let me see where that is. I have my CA certificate. So it's very similar to what we had before. We have the trusted roots. So as I mentioned before, we have the trusted roots for Let's Encrypt already in here. They are out of the box. They came from the template. You don't have to do anything. So, but I can add more trusted roots, and it's a simple process. You go in and say, create one, paste certificate. Then it says the same thing, submit to finalize. It thinks about it, and then it's done. And here is your trusted root. So it's valid until 2025. And let's go back, take this guy. No, let's take them. Take that again, just to show you the difference. Because if you just hear that on the slides, you will not see the difference. You go in here to the same document. It's yellow today here, and you paste it again. You say submit request, and now it's green. So this was the manual flow in combination with the health check demo. So I would say this is already really cool. But with Let's Encrypt, it's much easier. So let's have a look. I already confirmed that the license. So and with the -C option, I got the server, the DSAPI filter. So the DSAPI filter is in place. So we have those two ACME accounts, and I will use the staging account. So let's have a quick look in here. So it has a name, and what each account needs is always an ACME directory URL. And this is really something that is provider specific. For the staging environment, you have this here. For a production environment that you would use as as soon as you're done with testing. This is a different URL. So that's the main difference. And what you also see here is the license terms, which are actually coming from the provider. So if you have a different provider and you put it in and you create it, once you submit the first request, it will generate an account, and that account will then will have the provider website. It's part of the protocol, and also the terms of services are coming from the protocol. So let's use that. Let's do one again. So let's do one OpenNTF to demo. We put in a couple of servers. So I want RSA, no, ECDSA, NIST P384. And you see, and it's coming from the global configuration that you can change. It has automatic renew 30 days. So this is on by default. And you could put in the kyrtool file name if you want to make this your default. And pretty much the next step you do is you submit the request. And we have to be quick. On the console, you see we have a pending request, and I enabled a little bit of debugging, and you see that the whole flow is going on here. And you see that the DSRP filter is responding to the request. Let's Encrypt is doing multiple requests from different network points because they're really paranoid about nobody hacking them and putting in fake requests. And so they are going from different network points, hitting the server multiple times. And because we had 3 different subject alternate names for the server, we got 3 requests, and they're requested multiple times. And you see here we only got 2 because one of them was already validated. So here's submitted, and now we have our certificate. So this is a staging certificate, and if you want to change that, you just go in here, put it to production, submit it again, and now it's using the production account to create the certificate. So you see now here in the account itself for production, it created an account for you. So this is really the account. And when you look into it in the backend, you will see that account has a private key, which is encrypted in the same way as the name, the key for the servers are encrypted. So it's all safe in the backend. So those are the basic demos. And I think we have maybe a minute for the DNS text API. Let me show that to you. So what I mentioned is we have the new Git repository. So in that repository, you have some documentation, and then you have a directory with the documentation for the providers and for the ACME providers. So we have documentation for the different providers here. The Let's Encrypt and the bypass and the zero SSL with their configuration. You can import them. You don't have to type them in. And we have a list of the DNS providers with all the details. And what you do is you download them from the DNS providers directory, and each of them has a DXL. The ones that are there today have DXLs. So I probably don't have to show how you import a DXL file. that is simple. It's import DXL. If you wrote one, you say export DXL. So in my case, I would probably, let's switch over to my production environment, and I will show you quickly how this could look like. This is my production environment where I'm using wildcard certificates, and we have the ACME accounts. So the ACME accounts look like something like this, right? This is very similar to the other ones. And what we need now for the ACME accounts are completely separate from the DNS providers, right? So the DNS providers, we have configurations. Let's have a look into Cloudflare, for example. You see, this is what you import, and we have like the reference information in here, and it comes with the documentation. So the rich text is imported through the DXL files, and if there are attachments for, if you have a provider that needs scripts, they're probably going to be also in the document to make it easy to download them. So, and then the operations look like this in this case. We have a lookup formula. Actually, this is the old one. Probably, let me show you a new one that doesn't have that. That's easier to understand. The DigitalOcean one is easier. So this doesn't look that wide. So you have a post request type, and we have a header formula where you put in the authorization header. And to make it easy, we have like a test formula that puts in some test data in addition to the formula, and then you will actually see what you get. And you can go in here and you can copy stuff and modify it. It's really for convenience when you build it. The next thing that you can do is you can also post or insert fields, like all the configuration fields are in here. And last but not least, we have request tracing. So the request tracing by default is sitting at right trace on error for troubleshooting. But if you build something and you really want to know how it works, you just enable it. And then when you run those requests, let's just do one. So why not take my production one? So I just go and submit it. So we have a new request, and then you see in the trace logs, here I have a new request. It started, and you see all the details, all the configuration parameters. This is coming from configuration. Those are the parameters that you add. Those are the URLs passed used. Those are the headers. Those are the results. And then the results are, if they are JSON, they are parsed for you that you can use them in add formula language. And once it is done, so we have a 200 status code. This one is still going. It takes a moment because all the DNS requests have to be in place. And here you go. My live certificate is updated. So I updated my ECDSA key. I have RSA and ECDSA keys on at the same time, and the server knows which to use for which server. So if you want to play around and want to see what the results are, I have a blog post with all the details, how you can use OpenSSL to query servers with all the details. And I would leave that here for the demo, and I will give you a little bit more details about what for troubleshooting before we go to the questions. I think we could go on for a lot of time, but this gave you a brief overview what can be done and how easy it is to set up. So this was all live, and this was even production. And I think, let me show you one last thing, because I have it in the slides also. So edit global configuration. Here's the place where you configure what your default configuration is. You can select what key type you want to have, the key size or the curve when you switch over to curves. So then you have curves. You can define what is your certificate provider, and if you want production or a staging environment as default, you can put in the certificate attributes. So that's all designed for convenience, that an admin just can go in and start using it, right? Okay, so let's switch back to the slides and go into more details. So you will get all the slides, and many of the things will remind you in the slides what we've looked into. Before we look into the troubleshooting, I have to tell you about two limitations, and HCL is really aware of them. But as you see, it's a lot of features, and there was probably not much more time to get all of that here in. So this is really the remaining place where some additions could make sense. This is the export and import. So the export is currently not implemented because you really need to get it right. For security, there is no second chance. So if they would have broken it in the first release, then it's hard to fix it, because this private encryption, the encryption for the private key, is really something new, and it's really safe, and only the server where's involved can decrypt them. And if you offer a simple export functionality, you would break that functionality. So it needs to be a well-defined interface, and so there's currently no way to export certificates. There's one workaround. You can export the certificates. You can't export the private key associated with those certificates, right? So the workaround to get the private key is that you create a private key externally, or you could take an existing KYR file, because you can automatically import them, and then you have them already in hand, and hand it over to the cert manager to astro it for you, and then cert manager can use it and create certificates with it. And the last step here is just you take the certificates and combine it with the existing key that you have. And also for that, in my blog, I have a way to automatically download certificates from the server through HTTPS with an OpenSSL command line, a very simple script that you could build and combine all the certificates and the private key that you already have, and put it into a PAM, put it into a P12. And what you can expect in future is that there will be some kind of functionality to export. So, and the same is for the import. Today, there is no import option for the private key for the same reason, because you have to find a secure way to pass the private key to the server, and that needs encryption to be in place. So there are workarounds, or no, I wouldn't call them workaround. There are already there's functionality that you can use. You can import existing KYR files, and you can import PAM files. So what you can do is you can put in a cert and a key as a PAM file to the server on the console, and then it creates a TLS credentials document, and you can start from there. So as long as you don't switch to a new key, and Cert Manager will keep the key until you do a key rollover, which is also fully automated in the backend, it will keep the same key for new requests, right? So this is all we have for known limitations. And now the last piece is troubleshooting, and I will cover this really quickly because you can read all of this in the slides, and I will only cover the highlights that are really important, because then we take the remaining time for questions and answers. Okay, the global settings, we covered them already. There's one important point here. When you want to migrate to a different server, I mentioned already, it's all encrypted in the backend, and it's encrypted for the Cert Manager server. So the ACME account keys are only encrypted for the Cert Manager server, and the TLS credentials are encrypted for the Cert Manager server, and also for all servers with access. So when you want to migrate to a different server, that is possible, but you can't do that from the UI, because just use the UI to click and say, please server, do what is needed. That would be a too easy step for an admin. So you really have to go in and say, load Cert Manager, migrate to server, completely uppercase, and then the server name. The server name can be the short name of the server or the complete canonical name with everything on it. The server will check if it finds the server name, because it needs to encrypt the private key with the server. It will try in a dry run to re-encrypt all the documents. And then when that is successful, if it's not successful, it will go and say, if it runs into more than 3 errors, it will stop. Because it wants to give you more information, not that you fix one issue and then you have another issue. So it will do a couple of re-encryption attempts first for different users, TLS credentials, and the user accounts for the ACME accounts. And if that succeeds completely, it will then do the real re-encryption, and then will tell you now the server is in client mode, and you have to start the Cert Manager on the new server. So also this will all work, I would say, automatically, not just automatically, like many of the other functionality that has put into Cert Manager. Okay, there are some commands and some tips. So the Cert Manager interval by default is 2 minutes. So I would say put it to 30 seconds. I put it to 2 seconds for my demo. So then another one that is important, you could say tell Cert Manager process if you want to keep it as 30 seconds or put it to a higher value. So no, I said it wrong. So it's the default is 30 seconds. You can put it to 2 seconds, so that it's in seconds, not in minutes. You can do tell Cert Manager process, and what you should do before you shut down a server, if you have the chance, if operation is in place, if you do a quit, that will stop the running request, which is not that nice. So Cert Manager has a tell Cert Manager shutdown. What it will do, it will acknowledge that a shutdown is in place. It will work on the last request and then cleanly shut down. Very similar to what Traveler does with the Traveler shutdown command that you might know. Okay, there are a couple of nodes and I parameters. I don't think we need to cover them in detail. I should mention that Cert Manager compacts its own database, because you will probably not be able to compact the database when it is in use. So this is also an automatic feature. It will, by default, if 50% of the database has free space, or if the database hasn't been compacted for 30 days, it will automatically compact the database for you. So the common issues in tracing, I don't think we need to go into all the details, but here's an example. And this is the error message that you will see most of the cases. If the DSRP filter is not loaded, or if no inbound port 80 connection is there, you will see that error message. And this error message is coming from Cert Manager. Other error messages might come directly from the curl protocol. So you get real curl error messages like, I can't resolve DNS, I can't reach that host. And you will also see native languages from the ACME protocol in the backend. Okay, we have logging. I don't think we need to cover that in detail. We have logging for the TLS cache, and there's only one logging that you should look into by default. It's the cert store cache log. That's one that I would recommend to look into. If you start playing with it, enable this first one, because it will give you all the details about what's going on, and you also see details about that in my blog. So I did a blog article, like I think this week even, with details about that and how you can use it for tracing. Okay, the DSRP has its own debug parameters, and last but not least, there's a hidden all documents view that gives you all the documents. So if you get an error message that has a unique ID, a node ID, you can go in and sort it by node ID or unique ID, and it also, has the cert manager server also listed. So if you have issues for the encrypted documents, you can go in here and see if the cert manager server is right. So it's a hidden view. As the usual hidden views, you just navigate it through the magic keyboard combination, and you can see all the documents for your convenience. So I think we made it in time, and we have 15 minutes for questions. So I think this is my record, I think.
Very good, Daniel. Yep, you're right on time.
Including demos.
Let me, just a reminder, if you, hopefully you're seeing my screen.
Yep.
And so, yeah, just a reminder, if you want to ask questions, use the questions pane in the GoToWebinar interface. So, Graham, you have the first question.
How's my audio? Okay.
Yes, sounds fine.
Cool. So we have more questions than we're going to be able to get to in the time. So what we will do is get through as many as we possibly can here, and everything else will collect into a blog post on the OpenNTF website in the coming days. The first question actually is outside the scope of this presentation, so I'll ask it and answer it really quickly. Is there a way to automate TLS certification for same-time proxy? And the answer is not with the Domino Cert Manager. In fact, Roberto typed in here that same time, oh, I don't have it.
Same time proxy is based on Tomcat, which is not a Domino server.
There we
go. So this is in discussion from what I heard with export, right? With exporting certificates, to have one way. You need to redirect the challenge, or in case of DNS challenges, you don't need another server to be involved in this, right? Because there is no flow that needs an inbound connection. So in future, that is something that could be leveraged. And actually, this would be also high on my personal wish list, that we can, as partners and customers, use Cert Manager also for other flows. Also, SafeLinks needs a P12. Also, the same time server, the same time community server needs a certificate. That could be automated with Cert Manager, right? Because it's using HTTP, and HTTP as soon as 12 is supported, you could use Cert Manager there as well. And the questions about the import and export, and especially the export, are all hitting that direction. You want to use existing certificates on the one side, and you want to use what you have with Cert Manager outside that scope. And you will see on my blog more and more posts about what you could do today with Cert Manager and how you could automate your flows in addition to what is there, because the Cert Manager has been built in a way that it could be extended. So if you see the manual flow, who says that the manual flow needs to be a person? The manual flow could be even an agent, right? Or a business partner or a customer writing an add-on for their CA. to interact with Cert Manager, right? You just need to kick off the process and you have to play back the certificates, and you could even leverage like the trusted routes that are in, right? This was a longer answer to your short question, but
I was going to say.
I take the opportunity to answer other stuff that I didn't cover in the slides because I really think it's important.
Absolutely.
Next question.
Okay, so the next question was answered or asked a couple of times and answered, but that is AIX level servers or System I, IBM I level servers. We do require either a Windows or a Linux server in order to use the Cert Manager.
Yes, in once like the DSRP filter might go away, this will be probably also available on AIX and OS 400, but you can't expect that Cert Manager will be ported to OS 400 because from what I heard, there is it's the answer that we got through during the beta time. The API support in the backend on OS 400 is limited at some point. AX is something, I don't know how big the demand would be, but what you really can't do if you don't have Cert Manager on AX is you can't make the AX server the Cert Manager server. And you probably, if you're an AX customer today, you probably have at least a Windows machine or a Linux machine. And so AX and OS 400 can be a consumer of the certificates already. On OS 400, there's one limitation. ECDSA keys are not available on OS 400.
That's a good clarification. And in fact, now that I reread the question, so you need either Windows or Linux to generate the certificates, but any Domino server can use the certificates.
Yes, any 12 server. And I know the question is coming up. There's no way to use Cert Manager or the DSRP filter. I got that question on my blog also in an older version, because even the DSRP filter is well hooked up with the backend. So it's all really built into core. And even the DSRP filter uses functionality that a Domino 11 server doesn't have.
Okay, Howard,
let's strike out that question that's on your list, probably.
We have another question. What's the difference between Let's Encrypt for Domino and the Cert Manager? Why would you want to switch to the Cert Manager if you're using Let's Encrypt for Domino?
So the Cert Manager is really more than just Let's Encrypt, right? One of the design goals was to get Let's Encrypt implemented, but as you saw in the demo, it's a lot more than just Let's Encrypt integration. Let's Encrypt integration is an important part of this new functionality, but I really wanted to show the manual flow, which is what many corporate customers will use that can't benefit from Let's Encrypt. So the Let's Encrypt integration that Cert Manager has full functionality for DNS providers, a very flexible interface where you can integrate with many providers. What you have with the Let's Encrypt implementations that are out there that are Domino integrated, I'm not talking about the others, right? There is Certboard and ACME scripts. They are full-featured scripts with DNS integrations and with ECDSA support. So they have all the functionality, and it's pretty tough to get all the functionality in, like certificate revocation, like key rollover, all the stuff that we didn't cover in detail, which is all there in Cert Manager. And the other aspect here is it is fully integrated. So Cert Manager and Let's Encrypt flows are really hooked together. And Cert Manager and the Cert Store database and the TLS cache are designed to work together. And it's all designed by the same team to really have the best experience that you can have fully integrated.
Okay, I think that answers
I'm gonna do a
that.
little picking and choosing. I'll jump in. Sorry, just looking at the time and trying to get through as many as we can. Kim asks, are SAN certificates supported?
So the SANs were in my demo. So
Okay.
of course, all the certificates are SAN certificates because today, thanks to Apple, the bar is really high for new certificates. They have to be SAN certificates. That means even if you only have one name in it, the CN alone is not helping you anywhere. So putting the DNS name into the CN doesn't help you to be accepted by Apple, for example, and others. So Apple was the driving force, but many others also requested this and enforce it. So you have to have one SAN name. So when you do a request for one host name, it will be always a SAN certificate. You will not only see this with Let's Encrypt or Cert Manager, you will see this all over the place. The second thing is what I showed. I showed you one example where we have 3 SANs, 3 subject alternate names. And when you look at it really carefully, I talked to one of the design partners who asked the question, hey, when we have multiple providers, we have to do multiple requests and we need multiple key files. Not at all. So it's designed in a way that, as I mentioned, if you have a DNS provider, it's triggered by the registered domain. So it could be you have one host name that is going to one DNS provider. You have another host name that is going to another DNS provider. And you could have one where you don't have a DNS provider and just have a HTTP challenge. So it would go to 3 different providers and put the challenges into place for one certificate request. And then it will take the time for the provider with the longest time to wait to propagate the DNS. So it will put all the requests and then it wait for the longest time to be sure that all the requests are in place. And then you get one certificate with 3 SAN names for 3 different DNS providers. So actually that is not documented at all, I think.
Oh.
But it's designed like this.
Howard?
Yeah, so we have a question. So are you able to export out a KYR SDH file to put it on something pre-version 12?
So you have to import it into KYR file because older servers only can do that. And everyone who was in the beta saw that there were like the document had on the fly a KYR file created, and it has been removed on purpose because now that it's all encrypted, you can't export anymore. And what you could do is you use the trick that I mentioned. You create a key outside, and then or you take your existing KYR key file and export it or import it into Cert Manager with the commands that we have shown, and then from there on use the Cert Manager flows to update the certificate, and then you need the KYR tool still to update the certificate. So you can take your existing private key, you mix and match everything into a KYR file, and then you are ready to go with an earlier release server. But there is no automation. There might be scripts. I have old scripts that I have laying around to do that. And also our Docker image does that. There are scripts in there doing that. In our mini CA that we have based on shell scripts. So if someone is on Linux, that is something that you could use. So there are many ways to do it, but really, and we talked about it, we're in the preparation to get the slides on today. It's really, the answer is get updated. There are many more good features in 12. And go and update the first servers, and you will see it's all stable. I'm running in production since day one. And even before that, with the latest beta, I went already and upgraded some production servers. So that would be my last recommendation for you guys. So do we have a final question or more questions?
I was going to say we've got a lot of questions. Thank you everyone for your questions. We'll take them offline. So Daniel, I'll be in touch with you. I'll collect all of the questions and we'll format them and get the answers, and then we'll put them up on a blog post. But thank you everyone for your questions. And Daniel, thank you for your detailed answers. We've been getting lots of feedback on just the quality of this presentation and the level of detail that you're putting in. So I will say thank you very much for your time and hand it back to Howard.
Well, thanks, Graham, and I'll second that, Daniel. This has been a fantastic presentation, a lot of interest, a lot of questions. Obviously, we'll try to summarize those and put them on the OpenNTF site. So I'd like to thank you, Daniel, and also thank Graham and Jesse and Roberto for helping out today. So we will send out an email in the next 24 hours to everyone who attended with the URL to the recording, as well as to the slides, and we will also post the link. It might take more than a day or two to get the questions answered, but that will be on the OpenNTF blog site. So everyone have a great rest of your day. Thank you.
Same for you. Thanks for having me, and it was a lot of fun doing a detailed demo. I think this is the first time that it has been demoed somewhere live like this. So enjoy the rest of your day. Bye for now.
Okay, thanks. Bye.